Greetings to Inchi Anwar and fellow friends. My name is Naganadish Vasudevan, 01DKM 22F 2015. Today I would like to present Engineering Mathematics Presentation Topic 1, Chapter 2 Trigonometry. So let's move on with the next slide. So I would like to talk about the introduction of trigonometry. Trigonometry is the study of properties of triangles and the trigonometric functions to be used for various applications. Trigonometry studies the relationship in mathematics that involves lengths, heights, and angles of various triangles. Trigonometry is about a study of the angles and dimensions of triangles, where one of the internal angles is 90 degree. Trigonometry understands the relationship between sides and angles of a right-angled triangle. Being one of the important branches of mathematics, every student should focus on trigonometry. This allows the students to understand the complexity of angles and dimensions in a very less time. So, there are several examples of applications of trigonometry. One of them is trigonometry in construction, trigonometry in criminology, trigonometry in flight engineering, trigonometry in marine biology, trigonometry in astronomy, trigonometry in geology. So for today, my teammate and I have chosen for trigonometry in engineering. So there are several uses of trigonometry in engineering. Based on the slide, I would like to talk about the use of trigonometry in making roofs. Trigonometry is what helps engineers to calculate roof slopes, ground surfaces, light angles, structural loads, and height of width of structures to design a mathematical graph that a constructor can use for construction purposes. The next example is a Ferris wheel. By using trigonometry, we can make sure that the angles are equal in the structure of the Ferris wheel. Trig allows the ferry wheel to balance and rotate properly. Moving on to the next example. In a bridge construction project, trigonometry is essential for determining just how long a bridge needs to be. A contractor might use right angle properties and tangent to determine how wide a river is, which directly determines the length of a bridge. So, the trigonometry in engineering. Engineers use trigonometry and other mathematical relationships to find close approximations to length and dimensions. In the design of large structures, engineers must ensure that forces acting on structure will balance so they remain stationary. Engineers use trigonometry to account for vertical and horizontal components of different forces that act on structures, thus determining that the structure will be able to stand without collapsing before it is even constructed. These strategies, based on mathematical knowledge, enable engineers to design solutions to problems that might otherwise be unsolvable. Although it may not directly address fixing real-world problems, it is employed in many different fields in order to create computer music. For instance, trigonometry is utilized, as you are likely aware. Sound travels in the shape of waves, and this wave pattern is achieved using a sine and cosine function. Here are several situations in which trigonometry and its operations are useful. So, learning the outcomes of trigonometry, you must first understand how to apply Sochatua. The next is understand how to apply Pythagoras theorem and also find missing sides in right angle triangles. This will be furtherly explained by my teammate, which will detail this topic in more depth. Thank you very much. I pass this on to my teammate.
Thank you to my teammate again. Now, my name is Ahmad Adil bin Isamuddin. My registration number is 01 DKM 22F 2016. Now, in my part, I will talk about the solution, mathematical solution with drawing of the theorem figures. Like we can see here, This diagram for the example that we given next. For the example 1, they are given right angle triangle. They are given 3 sides, and one side is unknown. We can use theorem Pythagoras to find the side that are unknown, and that is c square equals to c a square plus b square. And c is hypotenuse, and we want to find x, so we modify a little in the theorem. That is xcm equal to set c square, the hypotenuse, minus b square, and xcm equals to set 25 square minus 24 square. And we calculate using calculator, we can find that is x equals to 7 cm. Now, let's move on to the next question. Okay, in this question, they are given in the right angle triangle. They are given two sides with the value that is hypotenuse is 9 cm, and one of side is 4.5 cm, and we want to find an angle of x. We can use the most basic, that is sin cos tangent for the solution of this example. In this example, we use cos because cos is adjacent over hypotenuse. That is adjacent is 4.5 cm and hypotenuse is 9 cm. We can see that given that cos theta equals to 4.5 over 9, and x is theta equals to cos power of to the power of minus 1 times 4.5 over 9, and we are using calculator, we can find theta equals to 6 degree, and theta is x, so x is 60 degree. Now let's move on to the example 3. In the example 3, we are using a different approach to find the value of x. We can say that the example is similar to the previous question, but in this question, the hypotenuse is not given, they are unknown, and the angle they are given. So we want to find the hypotenuse. We can use tangent, like our example here, and then because tangent is opposite over adjacent, we want to find opposite, but we don't know opposite. We can use this, and tangent is 27 degree equals to AB, unknown, over 13, they just said, and AB equals to 13 times tangent 27, and AB we can find that AB is 6.62 cm. The length, now we want to find the length of x. We can use hypotenuse because we already know the length of AB, and from the hypotenuse, c square equals to sec a square plus b square, and x equals to sec 6.62 square plus 13 square. We can use calculator, and we can find that x equals to 14.59 cm. Now, for the conclusion, that's all for the example. For the conclusion is, we can say that trigonometry is a branch of mathematics that study how triangle, side, and angle related to one another. Its literal meaning is triangle measurement, but it go well beyond geometry. It became rigorous discipline in the 15th century when it was used for the solution of a right triangle. Or the calculation of length of two sides of the right triangle, given one of its acute angle and the length of one side. That's all from us. Thank you very much.